Okay, so Jose,
Okay, I'm here. I'm back.
waiting for Maria. Oh, she will come back. So this interesting case comparison with between the Morton case in 1846 and today is the lack of report, the lack of eyewitnesses. Uh, okay, eyewitnesses
Mhm.
1 century, 50 years ago, and today is the contrary. We have more and more data. It's a big data, and sometimes we are lost in the data. So uh, we have the same problem, but the relation to the data is opposite.
Yeah.
Not
Actually,
sure that she's coming back.
yeah. I don't know if she understood that we to use the same link as before.
I don't know if she had the time to read it yet. Yeah,
Yeah.
on the chat. Yeah, I'm not sure. Um, participant 4. Participant journal. Okay. So Anna, what do we do?
Hi, Samuel.
Hi, Anna.
How are you? We already sent to each of you, as you know, the link to Essex again. We are waiting to Minerva to access.
Back.
We are really sorry. It was a problem of the interface of Zoom with YouTube that knocked down the session.
Okay.
Okay.
Um, we tried to work it as fast as we could. I'm really sorry. By the way, I'm just loving to hear your work, and you are being an amazing chair.
Thank you.
Just, I don't know. We are not receiving any signal of Maria.
Okay.
Something happened. Please, I will be right back.
Next.
So maybe we can just discuss about the big data. How do you
Yeah.
harvest the big data? Are you using a algorithm or?
Yeah. Actually, with the I have a background on machine, some kind of background of machine learning, and
Machine learning? Okay.
the challenge was if how can you design. Actually, there are two challenges. First, how can you design a model that can be understood in a pattern of machine learning, and the second issue is what kind of data can you feed it to.
Mm.
And it may seem kind of easy to draw up the model. Of course, it's hard, but if you analyze thoroughly how the actors move, how their actions are done, how can you interlink all those actors around, actually, that can be done. Actually, the hard part here comes from the data because despite having a lot of data right now, the main issue here is that firstly you have to identify your sources, and that comes in handy when being an historian because you can analyze what kind of documentations that you have, and you have a thorough methodology to work them out. But when you're reading the sources that you have to specifically pinpoint out what kind of data can you extract from it. There are two types of approaches. The first one is that you pick up a source. For example, I'm working a lot with scientific reports from the early 20th century, the first reports of food tampering that were produced by accredited laboratories in Portugal. And essentially, I'm working out some key details. For example, what was the scientist that produced those results? What kind of inputs did he have? What kind of, for example, what kind of legislation did he use to back up his historical experience? And if you can ask that data and feed it positively into your model. So the big question here is how that you can extract the data. You can have an optimistic approach, that is, pick up your source and basically you pick up any data that you see that might come in handy in the future, and may or may not be the most accurate data for your model, but since you don't know yet what can be the most thorough, you can use it all. Or you first work so hard on your model as to define what kinds of types of data that you need to specifically transport that data into knowledge, that you first work around the model and then ask the specific questions to your source. Basically, at this point of my research, I'm more inclined to have the more optimistic approach, because there is so much data that you can have that is almost virtually impossible to know a priori what is the data that you will need, or what specific details are you going to have. So it takes a lot of work. It takes a lot of time to know your sources, but at the end of time, it can produce a massive amount of data that can be used not just only to model these kinds of predictions that we can have, but also other types of interactions. For example, interaction between scientists. It's very interesting to see that the modes of communication between scientists in the early 20th century, although much more diminished that we have now, they can show us lots of patterns in terms of what scientists what is the inspiration of certain scientists. And that can lead us to some interesting conclusions. For example, one of the primary findings that we had is that despite Portugal being a scientific outcast in the early 20th century, we found out that some practices that were considered they were considered innovative for the time were started to be introduced in Portugal and then exported to the major cities and major academies of Europe. So there's also kinds of fun data that you can find when you are mining all these your sources for data.
And also one of the difference, I mean, if I consider, for example, climate science, climate change science, and the comparison between today and maybe 20 years ago is the free circulation of data. I mean, for example, at the European scale, if you have European funding, you have to release your data freely to the public very, very quickly. And so this was not the case 20 years ago. But so the consequence is also that there is more and more data, and sometimes even on the same subjects, there is a kind of incompatibility due to methodology and the way you are collecting environmental data. Mm-hmm. So this is another problem. How to but on your model, might be very interesting to solve this problem of methodology of collecting data, not analyzing data, just collecting data in the field. I mean, for climate science problems, issues.
I think that one of the issues that's something that I faced in doing some chemical research, because I worked on previously. I worked on models for predicting how some catalytic reactions would be. What kinds of catalysts can be used for specific type of reactions. And when I wanted to look up a library of data for that specific catalyst I'm studying, we often see that each scientist makes up its own data, but although they share with the scientific community, there is not a great hub where you can previously interact those data with another data that was produced by another scientist. They can complete your information. And I had to do this job myself. I have to collect all the papers, all the data that were published from about the same reaction, about the same catalyst, but from different scientists. And the time that I've spent doing that, it almost cut me my research from about half the time. I spent half the time looking for information, half the time to making the models and make my predictions. And this is something that outside of the exact sciences can be done because it's not such a development as it now. If you can gather all the data, if you can gather it in a specific type of hub, then you can say, oh, this is connected to this, but if you see this, it can be helpful. You can see that thing, and if you make up all this process, if you make all of this network, just for having the network, you can have some particularly good insights of what the outcome that you can have, for example, for a reaction or for a specific decision-making process. Because if I'm looking for new catalysts for a reaction, I can or look for the new catalysts that are being produced, or to the various forms of that reaction can be made. And sometimes different scientists tend to name their findings with another nomenclature. Then it can make it difficult to interact all the different information. So I think the great leap that we can have with big data in the next following years could be a more educational approach to scientists and also to a public in general, as into how to manage your data, because your data may not today be fruitful for what you're doing, but can be very, very insightful on your endeavors to come, or just the next door scientists as well.
Yeah, that's true. So thank you very much, Jose, for this presentation of this discussion. So, and I think it's time to close the session. Okay, so I don't know what to do now. So just thank you, Jose Ferraz-Caetano, for this presentation, modeling the past using history of science to predict alternative scenarios on science-based legislation. And we also thank you, Maria Minerva Kalimak, for the philosophy and sociology of a specialty, the musings of an anesthesiologist. Thank you for this session, this discussion. On the next roundtable, we'll begin in 1 minute on this channel. Goodbye.